Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, NEET UG and other competitive exams. If you are interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. This is a non-uniform ring. Okay. This is a non-uniform ring. That means the charge along the ring is not a constant, it is varying.
Yes, sir.
Now, again, focus what that fellow gives in the question. Okay. At an angle theta with x-axis,
Yes, sir.
the variation charge, of course, this is a ring, so we will have charge per unit length.
Yes, sir.
The charge per unit length varies along the perimeter as a function of theta, as lambda is equal to lambda naught sine theta.
Varies along the perimeter.
Obviously,
Okay, I was thinking.
charge is on the perimeter,
Yes, sir. Yes, sir.
right? Lambda is equal to lambda naught sine theta.
Yes, sir.
So he has already given you one song. We
Yes, sir.
we have a choice to create our own new song, or we can follow his song. I would rather follow his song.
Yes, sir.
My choice. Next thing, it's a ring. We have already done for ring, and by intuition also you can say due to a ring at the center, right? We need electric field. Let's say O is the center. So find the electric field due to the ring at the center, right?
0. Oh, this is non-uniform.
So for a ring electric field at the center, again it's an obvious thing. I will feel it's a 0, but this is a non-uniform. But again, non-uniform, so what ring should be 0, right? How the variation is given is important for me to understand. So that means I am
Yes, sir.
trying to understand him, what that fellow has given in the question first. He has given lambda, which is charge per unit length, as a sine function.
Lambda is constant, but as theta varies, sine.
Lambda
Theta.
naught is constant.
Yes, sir.
Lambda is a variable. And
Yes,
as
sir.
theta varies, lambda varies. So lambda is a function of theta, where lambda is a variable depending on theta, which is also a variable.
Yes,
The
sir.
only constant that we can say over here is lambda naught.
Yes, sir.
Okay.
Yes, sir.
Now I have to understand how variation, how he has given. Just a little bit of glimpse of understanding. If you don't want to understand and directly solve also, we can do. Not a big issue. But just for clarity's sake, I am telling. Okay.
Yes, sir.
For clarity, or let us say for a little bit of imagination part, how are the charges basically distributed? I want to understand. It is given as a function of sine theta. Sine, first quadrant all, second quadrant silver, third quadrant tea.
First and second are positive.
First and second are positive charge distribution. Second, third, and fourth are negative charge distribution.
Yes, sir.
Also, sine 0 is 0, sine 90 is 1. So, from 0 to lambda naught, sine 90, then lambda will be lambda naught. When 0, lambda will be 0. So, first
Yes,
thing, only for my better understanding, first thing is that I want to understand how the charges are distributed. So first
Yes,
I understood that On the first quadrant and the second quadrant, the charges are positive. This is successful.
Yes,
Next
sir.
that I want to understand is along x-axis wherever the ring is there, lambda is 0. But at the topmost point, the lambda is basically lambda naught.
Yes, sir.
Same goes for the below fellow, negative charge on third and fourth quadrant.
It will be minus
Lambda naught over here. This much of thing is enough for me to identify that whatever is there over here, mirror image is there over here.
Yes, sir.
Clear?
Yes, sir.
Let me do a little bit of mathematics first, then come back to the further clarity of what I want to discuss. Okay?
Yes, sir.
One thing is, due to these positive charges, electric field will be downward. Due to negative charges, the electric field
will be downward.
Okay?
Yes, sir.
But let us start deriving this. So I will say at an angle theta, take a small element subtending an angle d theta at the center. Let the length of this perimeter be dx. Okay?
Yes, sir.
Having a charge dq on it. Fine?
Yes, sir.
The electric field due to this dq is dE, right?
Yes,
and this
sir.
dE makes an angle theta with the horizontal line.
Yes, sir.
Yeah.
Yes, sir.
As my charge dq varies from 0 to 90 degree to 180 degree to 270 degree to 360 degree, the direction of dE is constantly varying. That means I will first take
components.
Correct?
Yes,
So
sir.
here I have dE cos theta and here I have dE sin theta.
Yes, sir.
Let me write what is the dE first. So the electric field dE due to the small charge dq can be written as a dq by, let's take the radius to be capital R, okay, which is a constant for the entire circle, so I'm not much worried, no problem. Fine?
Yes, sir.
But dq itself is lambda into dx.
Yes, sir.
But if you remember this small arc, I can write dx is equal to r d theta. We have used this earlier.
Sir.
Right?
Yes, sir.
And lambda is given as lambda naught sin theta.
Sir, we are having charge constant. I mean, only for the first two quadrants.
We are having
charge constant.
Where?
Everywhere it's positive.
Everywhere.
In the first two quadrants.
But in the first two quadrants also where 0 degree, 1 degree, 2 degree, 30 degree, 45 degree.
Everywhere it's positive.
Everywhere it's positive, but not constant.
Yes, sir.
Right?
Yes.
See, you can think of it like Rahul Gandhi. Everywhere he is positive, but not constant. Sometimes you can't stop yourself, and sometimes you're like, it's okay, yeah. I do understand that he is Rahul Gandhi, but he is always positive. Okay?
Yes, sir.
So, anyways, moving on. So I'll write dq as what? dq is?
You already wrote lambda.
Lambda into what is dx?
Okay, r dt.
Yeah, but what is lambda first? Lambda is lambda naught sin.
Lambda naught sin.
And what is dx is r d theta. Okay.
Yes, sir.
So here I have k by r square. This fellow is a constant. Next I
Yes,
will
sir.
have dq. Lambda naught into r is also a constant.
Yes, sir.
Next I have sine theta d theta.
Yes, sir.
This sine theta I have got because he gave it in the question. This
Yes,
sine
sir.
theta that I have got because of his question. But the next cos or sine that I'm going to get is because of my statement. I cannot integrate a vector whose direction is variable, right?
Yes, sir.
So first, we can do whichever we want. So let us take d cos theta, okay?
Yes, sir.
So if you're talking of d cos theta, that means we are getting ex, right?
Yes, sir.
Can be written as, I will remove the vector form right now, just write the integral part. We can write it as d cos theta, right?
Mm.
What are the limits of theta?
0 to 2 pi.
0 to 2 pi, right?
Yes, sir.
Now let me substitute my entire story. K lambda naught by r. 1 r will cancel with r square, right?
Mm.
Integral of sine theta into cos theta into d theta, 0 to 2 pi.
Yes, sir.
Is this clear?
Yes, sir.
I can write this as sine 2 theta by 2.
Yes, sir.
2 sine theta cos theta. Sine theta cos theta, I can write it as sine 2 theta by 2. Right? Is this clear?
Yes.
K lambda naught divided by r, and I'll get by 2 also. Okay. In
Yes, sir.
integral of sine 2 theta
It too.
d theta and 0 to 2 pi.
Yes, sir.
I do not know much of the stories, but okay, I'll simplify and then I will tell you one of the ways to look at it. So let us take 2 theta as some L or something, right? Alpha.
Yes, sir.
If my 2 theta is equal to alpha,
Theta is by 2 and we differentiate.
here I want to tell you one thing.
Yes, sir.
In mathematics, I told you we will also find the limits of alpha. Limits of theta are 0 to 2 pi. So what are limits of alpha, right?
Yes, sir.
So when theta is 0, alpha is also 0.
Boundary conditions. Yes,
Boundary
sir.
conditions. When theta is equal to 2 pi, my alpha is equal to 4 pi.
4 pi.
Correct?
Yes, sir.
Now, if you remember in calculus integration, we have discussed what is integration in geometry sense?
Addition.
Area under curve. Graphical.
Oh, area. Yes, sir.
Correct? Fine.
Yes, sir.
As a mathematics student, I must have seen sine theta curve,
Yes, sir.
right?
Yes, sir.
And I have already found out the limits as 0 to 4 pi.
Yes, sir.
So just for clarity purpose, this is 2 pi,
Yes, sir.
0 to 2 pi. 4 pi means one more story.
Yes, sir.
Integral of sine theta is area under the curve.
Oh, yes, sir.
Positive area,
2
negative area,
times
cancel.
2 times pi r square.
This is not circular, mathematics student.
Yes, sir.
Sinusoidal we call it, right?
Yes, sir.
Till here is it clear?
Yes, sir.
if this area I will take it as some A naught, this area automatically will become minus A naught because it is in the negative direction.
Yes, sir. Yes, sir.
Similarly, because of symmetry, this becomes A naught and this becomes minus A naught.
Yes, sir. V0.
Clear?
Yes, sir.
So we can do all these substitution, substitute, do integration, upper limit, lower limit, all those stories. Eventually, I'll get it as 0. Right?
Yes, sir.
Think of it this way. Positive charge and negative charge. Due to positive charge, I said downward. Due to negative charge, also downward. So they will add up. Correct?
Yes, sir.
But we are talking of EX.
Yes, sir.
Now look at 0 to 90 degree and 90 degree to 180 degree are symmetrical with respect to y-axis.
Yes, sir.
And both are positive. Whatever EX in this direction, this positive fellow will have, the same EX will be in this direction also.
Yes, sir.
Because along respect to y-axis, there is symmetry.
Yes, sir.
Whatever EX 0 to 90 degree will have, it will be in that direction. From 90 degree to 180 degree, same amount of EX will be there in the opposite direction.
Yes, sir.
Obviously, they'll have to.
Yes, sir.
Same goes to 180 to 270 and 270 to 360. These two will also cancel each other. Therefore, we have to get EX as 0.
Vertical component should get cancelled.
Horizontal component should get cancelled.
Yes, sir. Even vertical.
We'll see. We don't know. Okay, let us understand the vertical component. What will happen? See, 0 to 90 degree.
Everything will be down. Yes, sir.
Okay.
Yes, sir.
0 to 90 degree. My vertical component, let us say it is some EY. Okay.
Yes, sir.
Due to this also, it will be EY.
Yes, sir.
Adding each other.
Yes, sir.
And because this is negative, but symmetry in magnitude is there, that will also be EY. This will also be EY.
Negative, positive.
All will add. Correct?
Yes, sir.
So that is our physics part.
Yes, sir.
This is physics part, and mathematically, graphically we have seen. Analytically also we can substitute, solve upper limit, lower limit, we'll get 0.
Yes, sir.
Now, EY part, let us see. The physics part we already figured out, EY should not be 0. Let us see mathematics, okay?
Yes, sir.
Same thing, everything is same. I'll have 0 to 2 pi integral of dE sine theta, correct?
Yes, sir.
So I will come to this story. I will get it as k lambda naught by r integral of sine square theta from 0 to 2 pi. Fine?
Yes, sir.
You probably know this. Cos 2 theta is equal to cos square theta minus sine square theta.
Yes, sir.
I can write it as 1 minus 2 sine square theta.
Yes, sir.
So remember, there is d theta. Remember, whenever you have sine square theta, you usually use this. So from here, I can get sine square theta is equal to 1 minus cos 2 theta divided by 2.
Yes, sir.
This clear?
Yes, sir.
So this fellow becomes k lambda naught by r integral of 1 minus cos 2 theta divided by 2 d theta from 0 to 2 pi.
Yes, sir.
So we have two terms, a and b. So I'll integrate a minus integral of b. Correct?
Yes, sir.
Let us solve that entire mathematics and we'll see. Of course, we have already seen we should not get 0, right?
Yes, sir.
Now let us do the mathematics and this. Okay, like k lambda naught by r. What is the first integral? First integral is basically d theta by 2 from 0 to 2 pi. Correct?
Yes, sir.
1 by 2 d theta. What is the second integral? Minus, I have again 1 by 2.
2 theta d theta.
Integral of cos 2 theta d theta. Again 0 to 2 pi.
Yes, sir.
Okay.
Yes, sir.
Mathematics student, I think I remember what is cosine.
Yes, sir.
Right?
Yes, sir.
Now understanding limits, same as this. If I substitute 2 theta is equal to alpha, my limits will become 0 to 4 pi.
It will be the same thing. Yes, sir.
So first let me write the first part. I'll have k lambda naught by 2r. Okay, 2 I am taking common for both.
Yes, sir.
Integral d theta is theta.
Yes, sir.
Upper limit minus lower limit should be 2 pi, right?
Yes, sir.
Is this clear? 2 pi minus 0 is 2 pi.
Yes, sir.
We are only worried about the second term. Correct? So for second term, I have integral of, instead of theta, I'll write it as 2 theta is alpha, right? I'll write it as cos alpha.
Yes, sir.
Another thing, whenever we substitute, we differentiate. So I'll get 2 d theta is equal to d alpha, right?
Yes, sir.
So I have something like d alpha divided by 2.
Yes, sir.
0 to 4 pi. Okay?
Sir, could you repeat that?
I got d theta as d alpha by 2.
Okay, okay. Yes, sir.
But limits from 0 to 4 pi.
Yes, sir.
Limits are from 0 to 4 pi. Right? I can take this half also out of the integration. I am not much worried about that. I am worried about integral cos alpha d alpha from 0 to 4 pi.
And yes, sir. It will be sine.
Let us study mathematics. Right? 0 to 4 pi, 2 pi.
Yes, sir.
First story. So if I'll call this as area A naught, this also will be A naught, and this area will be minus 2 A naught
Yes, sir.
due to symmetry.
Hmm.
So again, integral of cos theta from 0 to 2 pi will again give me 0.
Yes, sir.
And from 2 pi to 4 pi also will give me 0 because same story.
Yes, sir.
That means my second term should become 0.
Yes, sir.
So the answer will be the first term, 2 cancel. K lambda naught pi divided by r.
Yes, sir.
Second term will also become 0. But my Ey will not be 0. That I was sure using my physics earlier, right?
Sir, but if we take in terms of vectors, it will be 0.
In terms of,
Sir, because the positive charges are also down and negative charges are also downward, positive and negative should get cancelled.
so that is my extra effort. When you say positive is down and continue to say negative is down, how are you able to say down, down, down? Because you already used the vector effect of positive and negative. Then again, while substituting, when you substitute positive and negative, that is double damage. You said positive is down.
Sir, I mean in the downward direction.
Correct. That positive is down.
Yes.
And
sir.
negative is also down. How did you come to this conclusion? By using the vector intuition that you have, right?
Yes, sir.
Now again, mathematics also I will apply positive, negative, and intuition also I'll apply positive, negative. Minus of minus will become plus.
Yes, sir.
So that means there are no non-negative numbers in my life.
But we are trying to add it, no, sir.
I'll just give an example. So this is negative x-axis.
Yes, sir.
Ramu has walked 5 kilometers along negative x-axis.
Yes, sir.
What is the position? Position is minus 5 kilometers.
Yes,
I cap. Correct?
Yes, sir.
But I will say, no, he is already walking on negative x-axis, so minus 5. And he is walking along minus I cap. So minus 5 times minus I cap, it should be 5 I cap.
Yes, sir. No, it will be 5 of minus I cap.
Similarly, when you are already saying positive charges downwards, negative charges also effect is downward, already you have utilized your intuition of vectors,
Yes, sir.
direction. Now, when you again substitute positive charge, negative charge, you're doing minus of minus. You're using it twice.
Yes, sir.
Then in life, everything will become zero.
Yes, sir.
Is it clear?
Yes, sir.
Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.